starting back up again. Let's see what you guys came up with since you were working on this one yourself. Okay, on number 12. Anybody want to tell me what you got for your 2 parentheses here? Yes, Hannah.
I got x minus 2 squared.
Very good, because you would have gotten this, and then you notice they're the same, so you square it, right? A negative 2 times a negative 2 is a positive 4, but when you add them, you get the negative 4, which is your b in the polynomial. Very good, okay? All right, 13. Let's look at this one. All right, so we've got x squared in front, so we're going to do x in each one of the parentheses. That gives us x squared. And then we want to think of 2 numbers that you multiply to get negative 3, but they add up to negative 2. So maybe that can get a little difficult. So just start giving me some numbers that multiply to negative 3. Negative 3 and positive 1, or positive 3 and negative 1, right? Well, those are the only options, aren't they? So which pair adds up to negative 2? All right, so we're going to take the negative 3 and we're going to put it in the parentheses and the positive 1, and we're done. That's not bad, right? So you won't always have pluses in both. You won't always have minus in both. You might have one of each, a plus and a minus. Okay, let's look at number 14. 2 parentheses. Go ahead and put your x and your x. And then 50 now. Oh, negative 50. So options for negative 50. Negative 25 and 2. Or 25 and negative 2, right? You got to do both options sometimes. Or that's not going to add up to negative 5. Negative 10 times 5 is negative 50. And that adds up to negative 5, doesn't it? That's it. Good. So you're going to put minus 10 and plus 5. Very good. Okay. Let's look at number 15. All right. Same thing here. Go ahead and put your x's in, and we're looking for 2 numbers that multiply to negative 6, but they add up to, what is the b there? What's the number in front of that x? A negative 1. You don't see it, but you know it's there. Okay, so 2 numbers that multiply to negative 6, but they add up to negative 1. Negative 3 times 2 would be negative 6, and negative 3 plus 2 would be negative 1. That's it. So minus 3 and plus 2. Very good. Okay, 16. 2 numbers that multiply to negative 21, but add up to negative 4. You want to take a guess?
No. Wait, what?
2 numbers that multiply to negative 21, but they add up to negative 4.
Negative 7 and 3.
Yes, very good. You just debuted on our YouTube video.
Awesome.
Okay, so Nathan says negative 7 times 3 is negative 21. Negative 7 plus 3 is negative 4, so that's our 2 numbers, negative 7 and positive 3. Fantastic. So there it is in factored form. And you guys understand this is your answer, right?
Yes.
All right, and if you ever want to check it, just multiply out like you were doing in the previous unit and see if you get this. And then you'll know you did it right. Okay? All right, number 17. This time, our last term has a y squared. You really don't do it any differently. The only thing you're going to have to do is, because of this y squared here, you're going to have a y here. But you're still going to operate the same way. You need to think of 2 numbers that multiply to negative 6, but add up to negative 5. Negative 6 times 1 and negative 6 plus 1. That would be it. Negative 6 and positive 1. But do I need the 1 there? No, I can just put plus there because we know in front of the y it's a 1. Christmas colors. Okay, 18 is going to be the same way. So we have x, put our y in here and our y in here. 2 numbers that multiply to 48 and add up to 19. These are a little larger numbers. 12 and 4 would add up to 16, not 19. Excuse me?
16 and 3.
Yep. 3 and 16. 3 times 16 is 48, and 3 plus 16 is 19. So plus 3y plus 16y. Or you could, do you guys understand that it can be written the other way? You can have x plus 16y first and then x plus 3y second?
Yes.
Okay, because what's happening between the two parentheses here? And with multiplication, order doesn't matter. If I were to just say 5 times 3 or 3 times 5, and I made those two numbers up, you're going to get the same answer, right? Multiplication, order doesn't matter. Okay? All right. Now, let's look at this graph. The solution to a quadratic equation, remember those are quadratics that we were just talking about because they have a degree of 2. The solution is the x value where the parabola crosses the x-axis. Now, if I didn't state this before, quadratics are going to either look like this or they're going to look like this. And I think we discussed that in the previous unit. Yep, and they're called parabolas. That's really important. All right, so the solutions where they cross the x-axis can be called zeros, or just as a reminder, they can also be called roots. So, how many solutions do you see in this quadratic? 2. And what are they? Give me the ordered pair for each of the 2 solutions that you see there. Negative 1, 0, and negative 3, 0. Those are the zeros or the roots. It's where the graph crosses the x-axis. Okay, so it's easy to see when you have a graph, right? You just look at the graph, and where does it cross the x-axis? That's where the zeros are, or the roots, okay? But what if you have just the equation or the function? Remember in the previous unit where we had the polynomials, they were already factored out into 2, 3, 4 parentheses, and then it said equals 0 after it. We had to set each parenthesis equal to 0, and that told us where the graph crossed on the x-axis, right?
Yes.
And we had anywhere from 2, 3, 4 places where it crossed. Well, all we're doing right now are quadratics. So there's only going to be, there could be 2, there could be 1. Let me just, this is kind of going off of the beaten path here for a minute. But let's just say, so if it goes like this, of course you're going to have 2, right? When would it have just 1 0 or 1 root? What would the graph have to look like? No, it's going to be a parabola. It's going to be a U. It's either up or down U. But when would it just have 1 0? Where would it be located, Hannah?
One would go through the 0.
Nicholas?
Wouldn't it be a diagonal line?
No, it has to be.
Or it'd be to the side, and then it'd be.
No, I.
Go through the.
Wouldn't the vertex be like the only point on the x-axis?
Yes.
And then it'd be,
Yes.
yeah.
So it would. How would it look? The vertex would be on the x-axis, meaning like it would just. That was
It
terrible.
would just kind of skim.
It would just kind of right there, right? It would hit it and come right back up. It would just be 1 0 there because the lowest, the minimum, the absolute minimum of the parabola would hit the x-axis and then it goes right back up. Or it could be like this, right? And it's only going to have 1 location. Now, let me just say this too. It's possible that you wouldn't be able to locate the zeros if the graphs look like that. Those are said to have what are called imaginary zeros, and that is something that you will get down the road, I believe, in Algebra 2, unless it's at the end of this course, but I don't think that we do much with that. All right, so with all of that said, I was just trying to show you the different scenarios. In number 19, in order to find the zeros without looking at a graph, we're going to have to factor first. The previous unit, they were already factored. We just simply took the parentheses and set them all equal to 0. Well, now we know how to factor. So we're going to factor, get our own sets of parentheses, and then set each of the parentheses equal to 0. Kind of?
Yes.
Well, let's see. Okay, so let's take, yeah, I got a lot of blank stares there. So do this first of all. And then, now we have y. We're dealing with y instead of x. It doesn't really matter what variable you have. And we want to find 2 numbers that multiply to 9, but they add up to 6. That one's easy.
8 times 3.
3 times 3. So positive 3 and positive 3. So we end up with y plus 3 times y plus 3 equals 0. Or I told you to write it as y plus 3, the quantity squared, right? Well, you only have to do that if I'm simply asking for it to be factored. But these directions say solve by factoring. What that means is factor, but I want the solution. I want you to solve it. I want you to tell me what the zeros are, not just factor it. So when you get to this, what you're going to do is take each parenthesis, and in this case, they're the same, so you don't need to do it both times because you're going to get the same answer. Set the parenthesis equal to 0 and solve this little one-step equation. How do we undo y plus 3?
Y minus 3.
Subtract the 3, right, on both sides. So then we end up with y equals negative 3. So the 0, or the root for this function, is at negative 3. Now remember, it's on the x. Ignore the fact that this says y. This is just a variable there. So if it's one of the roots, that means that's where it hits the what? The x-axis. It hits the x-axis over here at negative 3, and this is a prime example of what we just talked about. It's going to look something like this, right? Okay, now I'm not being specific. My point simply is that it's going to only touch the x-axis at negative 3. Now, I do happen to know that it's facing up as a smiley face because I look in front of my function here, and it's positive, right? We discussed that in the last unit. Now, whether or not it looks like how I drew it, or it could look like, this is hard when you just have your finger. I mean, it could, that's terrible, but we're not discussing at this point how narrow or wide the quadratic is. Okay, my point simply is it's facing up, and that's where it hits the x-axis. And that's really all you need to do for right now. Okay? So the way you would write your answer is, so what is the 0? The 0 is at negative 3, comma 0, right? That's the ordered pair. Okay? So let's do number 20. Let's factor first, and then we'll set it equal to 0. So we have our x. Two numbers that multiply to 36 but add up to 12.
6.
So this is going to be the same again, right?
Yes.
So we just have to do one of them because it's just going to be the same answer. So subtract 6 and you get x equals to negative 6. So my ordered pair for the root or the 0, where negative 6, 0. The second coordinate is always going to be 0 because y is always going to be 0. If it's on the x-axis, you're not going up or down, are you? Okay. All right, let's look at 21. Let's factor this out. Okay, so we have x and x. Now, two numbers that multiply to 12 but add up to negative 7. Two numbers that multiply to 12 but add up to negative 7. How about negative 4 times negative 3 is a positive 12? Negative 4 times negative 3 is a positive 12, and negative 4 plus a negative 3 is a negative 7. Good. So minus 4, minus 3. Now guess what? We have two of these to solve, don't we?
Yes.
So x minus 4 equal to 0, and x minus 3 equal to 0. So yes, you add 4 to both sides. It's a simple one-step equation, and you get x equal to 4. And then you add 3 to both sides, and you get x equals to 3. But write them correctly. So what would the ordered pairs be? What are the zeros? 4, 0, and 3, 0. Write them as ordered pairs for me. Okay, so if you were to sketch the graph, that's where it would be crossing the x-axis. And because there's two of them, that means it goes through, it goes down through, and then it comes back up through. Okay? All right, you guys are doing great. Let's keep going. Okay, 22. Now this one, because there's a number and the a value is something other than 1, let's see if we can factor this 3 out first. It looks like we can, right?
Yes.
So we have 3 parentheses, x squared plus 7x plus 12. And don't forget we have this equals 0 here at the end. Okay, now we're going to factor this parenthesis down into 2 parentheses like we've been doing. So we know we've got our x in front, 2 numbers that multiply to 12 but add up to 7.
3 times 4. I mean 3 and 4.
Positive 3 and positive 4. Now at this point you're probably getting the hang of, without having to write, first of all, we're not going to set 3 equal to 0. Okay, so we're not going to do anything with that. This one we're going to write x plus 3 equals to 0, which you know ends up being x equals negative 3. And x plus 4 equal to 0,
Negative 4.
which ends up being x equals negative 4. So your two answers are negative 3, 0, and negative 4, 0. Very good. Okay, so 23, we've got some options here. 23 says solve by factoring. Okay. Oh, I thought someone had their hand up. Okay, so you would take each one of, really, and some of you missed this on the test. You're going to take, because there's a variable here, you're going to set that equal to 0, so it's just 0. And then you're going to do the 5n minus 3 equal to 0. This one's already factored out, isn't it? Yeah, so we're just solving it. Are you done? You're done? Okay, thank you. You go back to class if you want. Thanks. All right, so we're going to add 3 to both sides first. So we're going to get 5n equals 3, and then we're going to divide by 5, so we get n equals 3 over 5. Now, I don't want you to get confused here. Do you need another pass? You might. Can you see which one would be the answer? It would be, yes, it would be B. Now, I don't want you to think that that's an ordered pair. 3/5, 0 doesn't mean an ordered pair. Because it's not in parentheses, is it? It's in brackets. Because it's in brackets, what it's doing is it's saying, here's my two zeros, my two roots. One is 0 and one is 3/5. They're not saying 3/5, 0 like as an ordered pair. Because if they were, they'd be leaving off this 0 as an answer. Okay, so really you've got, it's hitting the x-axis at 0, 0, and it's hitting at 3/5, 0. But every time, this value here is always going to be 0. So sometimes you'll see the answer written in brackets saying, here are my two zeros. They're not writing it as an ordered pair. They're just writing it as your two zeros with a comma in between in brackets. Brackets are different than parentheses. Does that make a little bit of sense?
Yes.
Okay, so let's look at 24. We need to factor 24. Okay, so let's set up our parentheses. Put our equals 0. We know we're going to have x and x. So two numbers that multiply to negative 35, but add up to negative 2.
Negative 7 and positive 5.
Negative 7, positive 5 is negative 35, and it adds up to negative 2. Very good. All right, and then if you were to solve this, you would end up with x equal to positive 7 and x equal to negative 5. So which one would that be? B. Very good. Very good. You guys seem to be doing okay. Hopefully. Okay, 25 and 26. Are these the last two?
Yes.
Okay, good. We're going to get this done in time. Okay, number 25 is already factored, isn't it?
Yes.
Fantastic. So all we have to do is set each parenthesis equal to 0. We can do that. Okay, in the first one we're going to subtract 3 on both sides. So 4b equals negative 3. Divide by 4. And v equals negative 3/4. Oops, sorry. Okay, and then this one's easy in your head. V equals negative 1. So which answer is that? A, very good. Okay, and then in the last one, 26, it is not factored, so we need to factor that. What can we pull out of each of these terms first?
2.
A 2. So we have 2 parentheses. We're left with x squared plus 7x plus 6. Don't forget your equals 0 on the end, or you might forget the next step, okay? First, you got to factor. Then, if you're solving, you have to set each parenthesis equal to 0. Okay, so let's leave the 2 alone. Break this up into 2 parentheses. We're going to have x, 2 numbers that multiply to 6 and add up to 7. 6 and 1. Set each of these equal to 0, and you get x equals negative 1 and x equals negative 6, which is letter D. Oops. Okay. Yes.
When like in 26, in 25, when we do the ordered pair in the brackets, does it matter what order they go in?
They wouldn't. No, if you're just writing your two roots in brackets like that, it wouldn't matter if you said, like in this problem right here, over here, it wouldn't matter if you said negative 3 comma 4. I mean negative 3/4 comma negative 1 in brackets, or negative 1 comma negative 3/4 in brackets. But you're not going to put those two numbers in parentheses, because then I will assume you think that that's the ordered pair. And if you're writing it as an ordered pair, the y value is always 0. Okay? You guys are amazing. Thank you. And I'm glad that we had some extra people come watch the lesson. Perfect timing. We just finished.
Hi, Miss Wilson. Thank you.
You're welcome.
Bye-bye.
All right. I will